Algebra 2, Chapter 4, Section 4, Complex Numbers. Now, so far we've only worked with real numbers when we're trying to find solutions to quadratics. And if you remember graphically, what that meant was your quadratic could hit the axis in exactly one spot. Maybe the quadratic hit it in two spots. But there was also the scenario of the quadratic never hitting the graph at all. And we said that was no real solutions. Now the thing is, there are solutions. They just happen to be complex numbers. So what is a complex number? First, we're just going to talk about something um, where we just mean um, imaginary numbers. So we're going to use this word imaginary. Now, all I'm going to say here, this is a poorly named type of number, mostly because imaginary numbers do exist. But when they were first discovered a couple hundred years ago, the guy who wrote it down in his letter to his friend just said, I've got these solutions, they exist, but I can't imagine what they mean. And somehow that idea of imaginary stuck behind. And that's just because they didn't know. Your satellites would not be useful if imaginary numbers did not exist. So they work. They're there. We use them to model all kinds of things in math in very advanced ways, but um, it's just don't get hung up on what the English version of the word imaginary means. These things are real. We just had to separate them out from real numbers because it's really hard to draw a picture of them. I actually took a class called complex analysis where all we did was look at imaginary numbers, and it was very, very hard to draw the graphs. You would not believe what we had to go through. But where does this imaginary number come from? Well, the whole idea is we are not allowed to take square roots of a negative number because what number multiplied by itself could be negative? Uh, because if it's a negative times a negative, it's positive. If it's a positive times a positive, it's positive. So what we had to do is we had to just say, hey, look, we got the square root of negative 1. We're just going to call it I. And that's what it's going to equal. There, equals is powerful. That's what it is. Now, if you notice here, I do write it different. I don't write capital I, right? I don't write a little I like I would normally write if I was writing. I use a kind of a cursive I for that. And that is a very important little symbol there. It says, yes, we were talking about the imaginary number I, not some other variable. But if you remember back to all of your stuff that you've ever done in math, you've probably never seen I ever used as a variable, except for maybe a capital I as like a vertex on a geometric shape. But that's because it's a capital I and not a lowercase I. So we prefer to write it the nice clean way is like this. I usually write it with just kind of a little like backwards J almost is how I write it. Um, but we call this an imaginary number. Okay. Um, so how does this work? I can take any number that I would normally try to find the square root of, but if it's negative, I have to do one thing first. See here I have the square root of negative 27. I'm going to break it apart into negative 1 and 27. So those are my two things that are separate there. Now, square root of 27, well, 27 is the same as 9 times 3, right? So I can break that apart. And you can see here, now there are two of the things that I can actually take the square root of. I know the square root of 9 is 3. The square root of negative 1 is I. And the square root of 3 just stays how it is. Now, it is kind of important the order that we do things here. We always do the integer, complex, or like integer, imaginary. Oh, let me spell imaginary correctly. And then the root. We don't write it the other way because if I wrote 3 times root 3 I. You could accidentally confuse it and think that the I is inside the square root, which we don't really like, so we don't write it that way. You also don't like to write the I first. It's just not as clean. So that's how we write it here when we're writing an order. It's the integer part or the rational part if you happen to have a fraction, the imaginary, and then the root. So let's try this again. The square root of negative 216. So I break apart the negative, and then I just work on trying to find the root of 216. Now, one thing you can always do, I don't think 216 is a perfect square. Oops. 216. It isn't. But one thing I can do, just kind of as a little side note here, see if it's factorable by 4, 9, 16, 25, 36, 49. Just start checking the perfect squares, because if you can pull a perfect square out of it, you're pretty good. I bet it's divisible by 16. Nope. Dang, it's not. How about 216 divided by 4? Ah, there we go. So here, wait a second. Divided by 16. Huh, okay. Times 4 times 216 divided by 4 is 54. Now let's think about the factors of 54. That is the same as 9 times 6, isn't it? Um, 9 times square root of 6. Now, I can take the square root of 4 and I can take the square root of 9. The square root of 4 is 2. The square root of 9 is 3. The square root of negative 1 is I. And the square root of 6 just kind of hangs out by itself. 2 times 3, of course, is 6. I root 6. Now, one important thing here is that both of them were like 3I root 3 and 6I root 6. That's just the pattern that's there. It's not actually a thing. I mean, I could have easily just had 5I root 6. That's fine. All right. Now, before I go to the next video, no, I'm going to do this in the next video. So that's how you find square roots with negative numbers.